Look at the fifth question, children. In a parallelogram ABCD, E and F are the midpoints on the side AB and CD respectively. Show that the line segments AF and EC trisect the diagonal BD. Okay, so AF and EC trisect the diagonal BD means what we have to prove means DP is equal to PQ is equal to BQ. If we are getting that means this diagonal is trisecting. Okay, that means these three parts must be equal. That only we have to prove. For proving this, first what we have to do means let BD intersect AF and EC at P and Q. First we must give the points P and Q. Okay. Then AB parallel to CD and AB equal to CD, opposite sides of a parallelogram, which implies AE parallel to FC. Why? Because E is a point on the line AB and F is the point on line CD. So, AB parallel to CD, that is same as, that implies AE parallel to FC. So, AE parallel to FC means what we can say that AECF is a parallelogram. Because these two are parallel, so we can say that this forms a parallelogram. AECF is a parallelogram. So, AECF is a parallelogram. So, AECF is a parallelogram means what we can say that AF parallel to C or EC. Okay. EQ. So, AF parallel to EC means what? What we can say that EQ. This line must be parallel to this line because these P and Q are the points lie on to parallel lines AF and EC. So, we can say that AP parallel to EQ. Okay. And FP parallel to QC because P and Q are the points on two parallel lines AF and CE. So, we can say that AP parallel to EQ and PF parallel to QC. So, FP parallel to CQ. The first part, first we have to prove that this is parallel. Then only we will get DP is equal to PQ is equal to BQ. For that, we are considering triangle BAP. This triangle we are considering. Which triangle we are considering? BAP. BAP. This triangle we are considering. So, if this triangle we are considering means E is the midpoint of AB. Okay. And EQ parallel to AP. So, automatically what we can say that P is the midpoint of E is the midpoint of this one and EQ parallel to AP. So, Q is the midpoint of BP. Okay. So, in this triangle, E is the midpoint of AB and EQ parallel to AP. So, we can say that Q is the midpoint of BP. So, what we can conclude that BQ is equal to PQ. Because this is the midpoint, so this distance, BQ distance and PQ distance are equal. So, we can say that BQ equal to PQ. That you must put as equation number 1. Next, we are considering triangle DQC. DQC. Okay. So, in triangle DQC, F is the midpoint of DC. Okay, children. And PF parallel to QC, we know that. So, what we can say that P is the midpoint of DQ. Isn't it? So, P is the midpoint of DQ means DP is equal to what? PQ. So, first equation we got it BQ is equal to PQ. Second equation we got as DP or PD is equal to PQ. So, from this 1 and 2 we can club and write DP is equal to PQ is equal to QB. What is the meaning of that? That means AF and EC trisect the diagonal BD. Okay. See children, question number 6 is homework. So question number 2, 3, 6. From this exercise, 3 homework questions are there, 2, 3 and 6. These are the homework questions from exercise 8.2. So see the 7th question. ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersect AC at D. Show that D is the midpoint of AC. So they are given ABC is a right angle triangle right angled at C. So I written this C is right angled. Okay. Then AB is the hypotenuse, M is the midpoint of the hypotenuse, they are given. BC intersect AC at D. So BC intersect AC at D. This one. We have to prove that D is the midpoint of AC. Okay. So D is the midpoint of AC. We have to prove that ABC is a triangle. M is the midpoint of this one. And these two lines are parallel, means automatically by the converse of midpoint theorem we can say that D is the midpoint of AC. For proving this, first I am considering the triangle ACB. Okay, what is the triangle we have to consider? ACB. ACB, M is the midpoint of AB. So MD parallel to BC. Okay, so automatically MD parallel to BC and M is the midpoint of AB. Automatically we can say that D is the midpoint of AC by the converse of midpoint M. Second case is what? MD perpendicular to AC. That means it makes an angle 90 degree to each other. Okay. So MD perpendicular to AC. For proving that, we have to prove angle ADM is equal to angle CDM equal to 90 degree. Then only we can say that AMD perpendicular to AC. For proving this, first we must consider MD parallel to BC and AC is a transversal. Angle ADM is equal to angle ACB. Why children? Because these two lines are parallel and this is a transversal, therefore corresponding angles are equal. So angle ADM and angle ACB are corresponding angles. So these two angles are equal. Then angle ACB is equal to 90 degree. They are given in the question data. So angle ADM is equal to 90 degree. So MD perpendicular to AC. ADM is 90 degree means automatically what we can say that MD perpendicular to AC. What will be the third result? This question is very important. Okay. Third one is CM equal to MA equal to half AB. Okay. CM equal to MA equal to half AB we have to prove. For proving this, first we must consider angle ADM plus angle CDM. See that these two angles, it stands on a straight line. So by linear pair theorem, we can say that this equal to 180 degree. So angle ADM, we know that already it is 90 degrees. So automatically angle CDM also 90 degree. In triangle ADM, first we can consider triangle ADM and triangle CDM. These two triangles, if we are proving these two are congruent, then automatically the corresponding parts must be equal. Then we will get the result, the required result. For that, first we have to consider two triangles ADM and CDM. Okay. So ADM and CDM, AD equal to CD because D is the midpoint. So we can say that AD equal to CD. That only the first one. Then angle ADM is equal to angle, next one CDM, 90 degree. Okay, here we got it. Then DM equal to DM common. So we can say that these two triangles are congruent by SAS congruency, two sides and one angle. So we can say that these two triangles are congruent by SAS rule. So these two triangles are congruent means automatically we can say that MA equal to MC by CP, CT. MA equal to MC means what? M is the midpoint of AB. So MA equal to MB, that is equal to half AB. Okay. Here we got MA equal to MC. So if we are clubbing these two equations, what we will get? MA equal to MB is equal to MA equal to MB equal to CM equal to half AB, because this MA is same as half AB, DM is same as half AB, and MA is equal to CM. So we can say that MA equal to MC is equal to half AB, that is CM equal to MA equal to half AB. Hence the proof. Okay. So the quadrilateral lesson completed, children, because next class we are getting 2 weeks after only. Okay. So nearly 9 modules I am sending. That is not a big thing for you people. Daily little you can learn. Okay. Thank you very much, children.